Hello and welcome back to Mr. Powers Teaches Algebra. Here's an example we just did. It was terrible. I made a terrible mistake. Let's see if we can do the next one without making any terrible mistakes and get this done quickly. So we want to do one or two more examples in this video for you guys. Last time we looked at one where the degrees of the numerator and denominator were the same. And we got something looking a little like this. Now we want to do an example where the denominator definitely has a higher degree than the numerator. So now we're going to look at that. What does that mean? And again, we got our rules here, right? We got our rules. What's that mean? That means the denominator has a bigger, which was m. M is bigger than n. Then the x-axis is a horizontal asymptote. So right away we look at this and we know our horizontal asymptote the horizontal one is easily y equals 0. It's going to be our x-axis. In case you need to look at those rules again, right? We got these rules. Okay? There and there. But again, you can look at this and just imagine, hey, remember horizontal asymptotes happen at very large values or very, very small values for x. What happens when this gets very, very large? We get 9 over a really, really big number. It's going to be y equals 0 because that gives you 0. 9 over a really large number is 0. So that's the easy way to do it. Since we're on asymptotes, let's find the horizontal asymptote we did. Let's do the vertical asymptote. So what's the vertical one going to be? How do we find vertical asymptotes? It's where the denominator equals 0. So let x squared minus 9 equals 0. That's super easy. Add 9 to both sides. X squared equals 9. That means x equals plus or minus 3. So we got 2 vertical asymptotes with this guy. All right, good to know. There's a vertical asymptote. Here's our horizontal asymptote. Intercepts, let's find those and hopefully not make a huge mistake again. How embarrassing. Mr. Powers cannot do intercepts. Oh. Anyway, intercepts. First off, f of 0. So let x equal 0. What does y equal? Well, we get 9 over negative 9, which is negative 1. So 0 comma negative 1 is an intercept. That's going to be, if x is 0, that's our y-intercept. And so what's our x-intercept? Here we go. X-intercept. That's where y equals 0. So if we let y equal 0, we say, well, in other words, can we let f of x equal 0? Really quick, I'm going to say no. Nope. That's a big no. It can't equal 0. We could set it equals 0 and try solving, and I imagine we get a situation that we just couldn't deal with. But this is 9 over a, oh, yeah. This is always going to be a positive number divided by a negative or a positive. X squared minus 9. We can get a negative here. We can get positives here. But we are not allowed to put a 0 here. There's no way. Because remember, for a rational function to be 0, the numerator must be 0. So it's not going to happen. So, well, no biggie. So there is no x-intercept. Good information all around. We got our asymptotes. We got our intercepts. Time to start graphing. Hopefully I didn't make any terrible mistakes this time. 0, negative 1. So 0, -1, right about here. And actually, I think I wanted to do that in red. We'll just cover that up here. Okay, 0, -1. No x-intercept, horizontal asymptote at y equals 0. That's our x-axis. Y equals 0 here. So we can mark this baby up here. There's our x equals 0. There's our asymptote. And vertical asymptotes, x equals plus or minus 3. Okay, so we got one at -3. There we go. And we got one at +3. Mark that up. Okay, so we got 6 regions here, kind of, sort of. And we kind of know what one is doing. I'm pretty confident that right in here, this guy is going to be going down like this, kind of like an upside down parabola, and like this. And also, just from looking at it, I'm going to say that the rest of the graph is going to be kind of like this. Here. And here. This is my intuition. Maybe you got the same intuition, maybe you don't. But we can test some points. What are good points to test? I say 4 and -4 would be great points to try out, see where we get. And I'll tell you why. First off, I think we're up here. Because just looking at our function, this guy's always positive, almost always, because I got a squared number -9. So as long as that squared number is bigger than 9, I got a positive divided by a positive for my y values. That's positive. So that's my intuition there. But to be sure, to be certain this time, right? I made plenty of mistakes before. Let's go for it. Let's say f of 4. That's going to be 9 over 16 minus 9. That is 9 over 7. That's a little bit more than 1. Just a little bit more than 1. So, say 1.1 something. I don't know. It's 1 point something. It's a little bit more than 1. Let's see here. And then we have f of -4, which is going to be the exact same thing. F of -4 is 9 over 16 minus 9, which is a little bit more than 1. It's around 1. It's a little bit more than 1. So f of 4 should be a little bit more than 1. Should be right about here, actually. F of -4 should be a little bit more than 1. Should be, actually up here would be a little bit more appropriate. And so I would say I did all right. For a quick sketch, it's fine. Now that I got a point, I can make it a little bit better. It looks like my graph's going to hug those asymptotes a little bit more than I thought it was. And you want to try to make that as curved, as smooth as possible. And, sometimes I can do it, sometimes I can't. I should put on my gloves, help me on this graphics tablet. But there you go. That's the gist of it. That's what this guy's going to look like. And to be sure, we can double check our answers with GeoGebra like we normally do. And once again, what do we got? 9 over x squared minus 9. 9 over x squared minus 9. Let's give this a name. Let's call it F. There we go. And so, yeah, it's exactly what we thought. We can see that horizontal asymptote at y equals 0. We can see vertical asymptotes at x equals 3 and x equals -3. We got this loop here. We got a loop here. or a little curve here, and we got a curve here. So it's exactly what we thought. So we did pretty good on our sketch. Not a bad sketch. Not a bad sketch. All right, so that takes us at 10 minutes on this example. So I think that's good enough for this one. So until next time, enjoy doing math.